Okay, so let's give you guys some more practice. So differentiate this. Find dy by dx of this. Okay, so press pause and have a go. Okay, so to do this here, take the natural log of both sides. Take the natural log on the left hand side, take the natural log on the right hand side. When you take the natural log on the right hand side, this index is able to move out here. Okay, so that will then give you this. That will then give you this. Okay, so now use implicit differentiation. So that when you differentiate this, it will give you 1 over y, and because y is a function of x, you could do times dy by dx. It's you using the chain rule here. Okay, and then on the right hand side, visualize it as one block multiplying with another block here. So you've got to use the product rule here. So the product rule, differentiate this, leave this the same, and then later leave this the same and then differentiate this. So it will be, hang on, so visualize it as one block multiplying this block here. So the first step, differentiate this, leave this the same. So when you differentiate this, it will give you 1. Leave this the same, that will then give you this. Okay, and then the second part of the product rule is to keep this the same, differentiate this. So keeping this the same will give you x, and then you've got to differentiate this. So when you differentiate this block here, visualize it as like this. You've got the natural log of the bubble. The bubble happens to be the natural log. Okay, so when you differentiate this here, it would be 1 over the bubble here, and then you've got to times the differential of the bubble itself, which is 1 over x. That's why you get this here. Okay, well anyway, differentiating this will then give you this thing here. So now it's just a matter of tidying up. So this thing multiplying with this block here, and then they're all multiplying with each other. So this one gets multiplied to the top here, and then it gets cancelled out. So basically these two x's will get cancelled out, leaving you. So this whole thing here would be this here. Okay, and then well, this remains the same for the time being. So yeah. So now you got to so now you want dy by dx on its own. So times both sides by y. So that will then give you this. Okay, and remember, when you use implicit differentiation, you most of the time you're going to get y on its own like this. So revert back to our original y. Our original y was this. So now it's just you putting this back into that y. So this is our original y. So put this y into here. Hang on. Put that y back into this thing here. So that will then give you this. Okay. So now it's a matter of this times this, and then this times this here. So hang on. So visualize it as this. You've got one block here multiplying with this block here. So that's this block. That's this block here. Okay, and then this one here is this one here. And then when you multiply this with this thing here, you will get something like this. Natural log of x to the power of x over natural log. So exactly the same thing here, exactly the same thing here. Remember that. Remember from indices. If you have this here, xb here, then that becomes x to the. So basically, it's just this minus the 1 here. So it becomes this. Okay. So overall, your answer would be this. And just to check for yourself, get a graph plotter, plot the original y here. This was our original y here. It will then give you this red line here, and then plot the r derivative, which was this here. It will then give you the blue line. So have a quick glance. It does seem to make sense. Yeah, it does kind of make sense. If you really want to, you can, depending on your on the quality of your graph plotter, you can zoom into this bit here, and then you can tell that the gradient around here, if you keep on zooming in, you will find that the gradient is roughly 1 around this point here, and you can see that the gradient around here, the derivative here is 1. So well, when you differentiate things, get a graph plotter, plot the original y equals blah blah, and then plot the derivative, and then you can use a graph to check your answer. It's not perfect, but it gives you a rough idea. Well, if you get something silly, your graph will look really silly as well. If you get something like this, I don't know, then you can detect if you made some silly mistakes. Okay, so get a graph plotter and plot it. It will help you get a rough idea if your answer's right or wrong. Okay.